Thank you, everybody, for allowing me the time to be here today and talk to you about the ORBOT, the surgery suite of the future. Before I do that and get to the ORBOT, I'm going to talk a little bit about what the industry says is going to happen. So it says traditional operating rooms are giving way to interventional platforms that can support new surgical techniques and technologies. And this is from Stanford Hospital, the doctor that runs their ergonomic system there. The surgery suite of the future must have, in my opinion, advanced capability, enhanced visualization, larger space, integratability, increased efficiency, artificial intelligence, connectability, and I'm going to give you a 5G primer here, and better ergonomics. So moving right on, the advanced capabilities, robotic systems will continue to migrate to cobotic systems, which is the combination of both human touch and automation. And the robotic systems will become smaller, more compact. They'll have hepatic sensors in them to allow them to move with the surgeon, with real-time diagnostics, and of course, our special focus, augmented reality headsets and 3D monitors. And all this is made even more possible by 5G edge computing. We're bringing that to the surgery room. Enhanced visualization, the old standard optical microscope will soon be replaced with an all-digital operating room featuring a virtual reality platform that will replace the SOM and the AR headsets that we're doing, we call the OR lens, which is 3D and gives you holographic images. Also, we've got our stereoscopic 8K 3D glasses-free monitors, which will soon be in all the ORs, just like the AR headsets, and device tracking in every OR. So the operating room are going to get larger. They're going to go from 400 feet to 800 to 1,000 feet, and they're going to feature more things on the ceiling than to try to free up space on the floor. The integratability, right now the lack of integration is causing some loss in efficiency and potential impacts on the patients. And so there's going to be improved integration technology like the hybrid ORs, which along with 5G Edge will enhance communication coordination between services and to reduce cost. The AR 5G headsets can permit virtual instantaneous download of a 3D pre-op in seconds. Also, we got the holographic presentation on the headset, so the surgeon gets a holographic view that he can twist and turn, actually align with the organ itself, so they can see exactly where to make an incision or a resection. Increased efficiency. The hybrid ORs are the latest in the merged technologies combining radiology and the surgery platform where multi-stage procedures can be done. For instance, before they close up a brain tumor patient, they can do an MRI, make sure all the tumor's gone before they actually do the closing. And there's going to be increased minimally invasive surgeries in the future. Artificial intelligence, beyond just the diagnostic imaging that's happening now, can prevent near misses of surgeons making a mistake, give surgeons a choice prompt where a prompt comes up and says, most surgeons would choose this size incision right here, capturing instrumentation errors, so you can do the artificial intelligence can look at your surgery plan and then run a routine and make sure that all the instruments are actually dialed right, so for the surgery. And then we'll have a review, fix, and share feature where if a surgeon runs into a problem during surgery that wasn't expected, they can review that on a video, they can fix it, and then they can share it with other surgeons. So the connectability, 5G edge computing, what that is, it's returning cloud-based functions to the localized networks to reduce latency and increase data and users at the same time. So think of a surgeon downloading into an augmented reality headset a huge 3D MRI video file, and he can do it on 5G Edge in milliseconds instead of tens of minutes during the surgery, making the surgery more efficient, his performance better, and safer for the patient. A surgeon, I was recently quoted in Forbes, the surgeon needs to have less than 10 millisecond delay which the 5G edge provides to them. And so relying on resources in the cloud is just not realistic anymore. So this is the 5G edge transformation, and basically it's all about the bandwidth. And you can see as we move over to the right, we're getting increased bandwidth by having more towers within a localized place, and that's all about 5G. So 5G also, edge computing also allows you to do a prioritization scheme so that some traffic would be pegged as prioritized, and it will always go through first and faster than low priority stuff. And so we're up to where we can get like 100 megabits a second and 10 gigabit peaks. And so by that way, we can get more people, more information in the OR. Here's kind of what this is courtesy of AT&T. We're actually, Ocutrx and AT&T have contracted together to provide a platform for the surgery suite of the future, bringing in the 5G edge. This is courtesy of AT&T, and just shows how we're basically networking a hospital or localized location. So what's the problem again? Better ergonomics. A American Academy of Ophthalmology survey recently showed that 51% of the surgeons experience pain during surgery. 15% of them have to reduce their surgeries because of the pain, and 7% have to get surgery themselves or retire early. And that's not a good idea. So what's the problem with the current legacy systems? So the legacy systems cause neck strain on the surgeon, that they're fixed, and they're this huge, gigantic piece of metal that's right in the way of the surgeon trying to do the operation. The resolution in some of the new heads-up displays, which is a monitor, is not true 4K to the eye. And most surgeons, we've done a survey of over 700 surgeons, until they get true 4K in each eye, they're not ready to give up the old standard optical microscope. And so some of the newer systems have a monitor, a 3D monitor, but they have to wear 3D glasses. And so the 3D glasses block either 50% of light or 100% of light, depending on which phase they're in. And that's not good because it reduces the resolution, it reduces the ability of the surgeon to see. So we've got Dr. Bill Link, PhD, a super KOL in ophthalmology, recommending the ORBOT. So what is our solution? So we use a novel approach because, unlike most other surgical device makers, we don't start with legacy equipment and try to figure out how to add on something. We started from scratch. We got state of the art for every piece of the equipment. So here is the ORBOT as it's seen in the surgery room, and I'll tell you some of the features here. So basically you have 3 different visualization methods. You can wear the headset, you can look at the 3D television without having to use 3D glasses, or you can look in a microscope view, which is really a VR. You're looking at 4K micro displays in each eye. We've got Ocutrx wireless technology that basically transmits video to the headset as fast as an HDMI cable, so that all 3 of these things, both the television and the mini lens being hooked up wired, stay exactly the same pace and are showing exactly the same frame at the same time. Of course, they have the 6-axis cobiotic arms, and cobiotic again means just the combination of being able to speak to the arm and have it do something, be able to touch it and it will move with you, or it works automatically in a pre-programmed manner. So the surgery suite of the future in the ORBOT, it moves automatically on a track wirelessly with fiducial markers on the floor to go to a retreat position before the surgery and then go to an active position during the surgery. If the surgeon needs to move to a different side, then the ORBOT can automatically follow its track to the other side. The state-of-the-art surgery overlay, what we call med tiles, this is where we can give the doctor the surgery feed in the headset, but if he looks to the left or looks to the right, he can also see patient vital information and tool and mode of the operation information that's virtually presented like you see down at the bottom there. Our stereo lens, which is our 3D 8K monitor, provides that 4K. Most other heads-up manufacturers right now, they're using a 4K television, which when you divide that into 3D with the 3D glasses, only gives you 2K of resolution to the eye, which is generally not sufficient to really see, particularly not in ophthalmology, where they're having to scrape something like a moth's wings off the back of the eye. So ours is 8K, which means each eye gets 4K of information, and we do that by putting lenticular lenses on the display itself, so the 3D is projected out and there's no degradation in the brightness. So here's a short video talking about the stereo lens.
Yeah, that's pretty phenomenal. So I certainly can't say I've seen anything like this before without the use of glasses at all. This is pretty awesome. Honestly, from a clarity standpoint and depth of field, it really looks quite amazing. Any sort of surgical advancement can only occur with, again, proper surgeon positioning and comfort. So if the surgeon's comfortable, surgery is going to go much better. And so that's really kind of the first thing. But the second thing, especially from a retina specialist standpoint, is depth of field and clarity of what you're viewing is absolutely critical. And this is the depth of field and clarity on the screen is absolutely phenomenal. So I think if you're looking at the ORBOT from a future surgical standpoint, that's going to be amazing to have that depth of field and that clarity in a picture of your surgical environment, of the retina, of membranes that you're peeling, to be able to have that clarity and depth of field without any external devices attached to you or aligning with them is going to make surgery easier, and it's going to make it safer for the patient.
So the mini lens, again, is the microscopic type view, and the mini lens has sensors in it, has SLAM sensors in it, and if the surgeon calls for it, it will actually come to the surgeon's eyes, then hover about 16 millimeters away from the surgeon's eyes, and if the surgeon needs to stretch or move, it will actually move with the surgeon when he wants to move. This is the Ocutrx again that sends the video wirelessly as fast as HDMI. 4K video as fast as HDMI cables. The 6-axis cobiotic arms can either be voice activated or can come to you automatically, or you can move it and work with it. So typically a surgeon would want to touch it so he can just talk to it and it'll come to his eyes. The OR lens is our featured headset. So I'm going to talk about that just a little bit. Here's another short video.
Hi, I'm Dr. Thomas Finley, Chairman of the International Medical Advisory Board of Ocutrx Vision Technologies. Retina-related surgeries and procedures have for a long time been associated with significant neck and back strain on the part of the surgeon. More recent developments have led to a significant improvement. However, surgical positioning is still not optimum. The Oculens headset has the potential to dramatically improve both surgeon comfort and ergonomics, while at the same time providing a crisp and clear surgical view. Better visualization and better ergonomics lead to better outcomes. There's no doubt this is the next step in the progression of the heads-up surgical display.
So here's a little bit of an analysis of our competition. All of these, both Magic Leap and HoloLens and Bionics, all use waveguide type technology. They're all heavy, they have a limited field of view, and they're all less resolution than our headset. Most of them block most of the light, and you can see with the Magic Leap up there, it'd be hard to walk around and move around in a surgery room. And the HoloLens 2 uses a laser where they're shooting 1 million nits into your eye. Compare that with your cell phone of 1,000 nits. If that laser ever stops or slows down, you've got a retinal burn. Also, the HoloLens, this is particularly for the HoloLens, this is actually off the internet, and their secret is out that they're having big problems with their chromatic aberrations, and so that we don't have that same thing. Our competitive advantage are we're the lightest from about 250 grams, the highest resolution, up to 60 pixels per eye, which is the highest resolution that the eye can see at 20/20. The widest field of view, 60 degrees wide in each eye for a total of 120. Has eye tracking patented eye tracking technology inside the headset, so that the surgeon's voice command can be followed by a eye tracking command, so that in case the voice is muffled or something, it gets the correct command. Our dynamic opacity darkens the screen on the outside so that you can see the virtual image better than the real world. And if you were trying to overlay a heart on a heart, then that would probably turn it to about 50% by talking to the headset, so you can see the virtual image and the real image, the real heart behind it. We have a hot swap so that it stays active even if you have to change the battery during the surgery. We've talked about the Ocutrx. We've got artificial intelligence. It's both machine learning and AI, and the 6 degrees of freedom. So this is for neurosurgery, for oncologists, for orthopedic surgery, for ophthalmology, that's where we started, and for interventional radiologists and more. So we can use this in a variety of ways. And here again is the surgeon looking at the virtual heart, but in reality, he's overlaying that virtual heart over the real heart. And again, since it's 3D and we created our own 6 degrees of freedom, which allows us to pose that image there, then he can rotate and get the orientation and the registry right, so that the pre-op MRI of the heart that he's looking at there is exactly overlaid over the real heart. And that way you can be more precise in the surgery. If you're doing an ablation, instead of looking at a 2D image of where that line should go to freeze, and then looking back at the real heart, you have where the techs have actually drawn the ablation line overlaid on the real heart. So this will increase precision of surgery, be more safe for the patients, and actually increase the efficiency of the surgery and reduce the surgery time. So we have 3 types of headsets. We have one headset for the surgeon. We have that does everything. We have another headset for an attending tech that does most of the things. And then we have another headset that's lesser cost, of course, for students that basically they just get the visual information. So we can actually have a surgeon in London, let's say at Moorfields Hospital, with the headset on, and maybe one of the doctors in Uganda that trained with them is doing a ophthalmology surgery in Uganda, and the surgeon in London can go right here, no, right here, this is where you need to scrape. And because we control every pixel and we know the size and position of every pixel on the XY axis, then an exact fiduciary marker will show up in Uganda to that surgeon that's learning and show him exactly either where to scrape or where there's a caution or where to be careful. And so we're promoting telemedicine, and this is all possible with 5G, where we reduce the latency of the overall internet from 80 milliseconds down to about 20 milliseconds for remote surgeries and 10 milliseconds within the surgery suite itself. So if a surgeon wanted to download this picture, it would start loading in 10 milliseconds delay only. So here's our field of vision. You can see magically in HoloLens and HoloLens 2, we have the widest field of vision, so that provides the surgeon with more relevant information to see the surgery site that he's working on. This is the dynamic opacity. Again, if we were showing Mickey Mouse on the inside of that's what was being projected on the lens, and he was walking across the lens, exact shadow, not exactly pixel for pixel, but almost pixel for pixel would be shadowed on the front of the lens. And what this does is allow our glasses to be more see-through, but then still be able to block the real world light so that the virtual image is brighter than the real world image, so the surgeons can see it very clearly. And again, if they want to see real world and virtual image, we have a gradient from 0 to 100. They can turn down the dynamic opacity down 100 to 50%, down to 10%, whatever they need. We also have a neural matrix which is our neural engine. And we're working with Daniel Ting, who's recognized as one of the world's preeminent artificial intelligence surgeons. He's a MD and PhD, and he's written about 300 articles on artificial intelligence. And so we have our med tiles, which allows the surgeon to see outside, all that information captured, so we can put it through AI algorithms, and then we can do that predictive thing that I was talking about before, predictive choices for the surgeon, make sure that all the settings on the instrument is correct, and then do a review and change if the surgeon wants to change a procedure or how they do it. So way beyond just the data imaging that AI typically does right now. This is also for interventional radiologists. Oftentimes they have to touch the screen, as you see, and then they have to go back and get sanitized. And so with our OR Lens headset, they have virtual images and virtual menus, and they can use hand gesturing to pick things off the virtual menus. So during that interventional radiology, which they might be actually putting a probe in or something, they can see the patient, they can see inside of the patient at the same time, and they can have virtual menus to choose from to either record or stop the recording or that kind of thing. We also have, during COVID, we invented a telemedicine. We call it remote medical presence, where you can actually get on and call the doctor. Our headsets, because of AT&T, are wireless connected, VoP connected, and also cellular connected. And so you can get on and talk to the doctor. This particular version will take respiratory rate, blood ox, blood pressure. It has the eye tracking in it to see if there's concussions or anything is wrong with your eyes. Also, we can do visual field test within the headset, something that like a Humphreys visual field test machine that costs $25,000 in a big box, sits in a doctor's office, now is reduced to just right in our headset, where you can see flashes of light and shooting stars. You click or you say to the headset when you see those. When you don't, then that outlines maybe where a defect is, like a macular degeneration scotoma. So you can do remote medical presence, and then you have a camera that the doctor can see you, you can see the doctor, and you can pull it off, stick it in your throat to say, how red is my throat, or show the doctor a rash, that kind of thing. We started out actually doing low vision correction for macular degeneration and other low vision problems, where we basically do that visual field test I was just talking about. That then the software knows where the scotoma is as if it was presented on the lens, and then we move all the pixels out so that all the pixels in the streaming video that the headset is taking are there, but none of them are displayed in the area of the defect. So we've done clinical trial, our first clinical trials. Everyone was, you had to have not been able to read for at least 1 year, some of them up to 4 years. Put our headset on, within about 15 minutes, they were reading normally again with large scotoma macular degeneration. We can also help kids with amblyopia by using the dynamic opacity to frost one side of it, have them play games, and now for the first time ever, the pediatric ophthalmologist gets an immediate printout, because of the eye tracking, of what the lazy eye has done during the day, and so we can change what the kid sees or what the game is to make them go further to the left or the right or whatever. And this is the first time you get an empirical data printout of what that lazy eye is doing. We can also tell how correct they are aligned and how incorrectly they are aligned. And so now the doctor has really evidence, not just guessing and looking, to show what's happening with that eye. And then as the lazy eye gets better, we reduce the dynamic opacity, so it's the first time that anyone has had a binocular recovery from amblyopia, and bring that strong eye back in weaker, so that they both end up the same. We've got a great medical advisory board and key opinion leaders both here and in Europe, and we're taking the ORBOT both here and in Europe. So that's the end of my presentation, and I'd open it up for any questions.
Thank you, Michael. That was an amazing presentation, and Everyone, him and his team, Victoria, Mary, they're always available via email and phone, and we can always connect you to them if you're interested in potentially collaborating or hearing more about his innovative technology.